Okay, welcome, Candia and Riley and Alejandra and Zach and Brenda and Bailey and Alex and 0049. This is the week 3 webinar of the Online Elementary Statistics class. And what we're going to talk about today is a few things. We have 2 chapters to go over, but not really 2 full chapters. I'm picking and choosing on the sections we're looking at. So we're going to be looking at chapter 4. And in chapter 4, we're going to be looking at the expected value and standard deviation of a discrete distribution. We're also going to be looking at the binomial distribution. So those are the 2 different things we're looking for chapter 4. And we're not doing the rest of chapter 4. And similarly in chapter 5, we're just doing a part of it. We're going to be looking at what a continuous distribution is. And we're going to look at a uniform distribution. It's the easiest kind, and that's why we're looking at it for the continuous distributions. It's not the most important kind, but it's a nice kind of get your feet wet way of exploring continuous distributions, because we're going to be getting the more difficult one, which is the normal distribution, next week. The other thing I want to do, and I'll probably start a little with that, is just go over some project thoughts and answer any questions. And again, what the main point of having the webinars live is so I can answer questions live, and you can ask and I'll be able to answer. So a couple things, and I think you all know this, hopefully, and that is the project is due. The final due date is a week from Sunday. So the final due date is a week from Sunday. And that is what, May 5th, I believe, is the final due date. But don't wait until the last minute to submit the project, because you can't submit late. It's not good. So that's one thing, is that you want to do it ahead of time. And more importantly, a week from Wednesday, I kind of want to go through the timeline backwards. So what I recommend is a week from Saturday, you turn your project in. And that way, if something goes wrong, it gives yourself 24 hours to deal with it if something goes wrong. I know it's something that most of you probably aren't used to, but it's a good life skill. Is that if you have something really important and there's a due date for it, try and get it done the day before instead of the day of, because that way, if something goes wrong, you got a backup plan. So it's just it's not just for this project, but for your life. It's just a good idea if you can. But a week from Wednesday or earlier, if you want me to take a look at your project and give you feedback so that you can improve on it, then you email it to me. Do not submit it as your project submission, or that's your final submission. So instead, just email me your project, and you could do that through Canvas. There's an email thing, or you can just email with my email address. It does the same thing. And then I will take a look at it, read through your project, and then I'll write down kind of the top bunch of things that you can improve on. What I found is those who don't do that, very few get A's. Those who do it, a lot of them get A's. Okay, no guarantee, of course, but a lot more get A's, because you're a bit in the dark on the project, because, again, you have a list of things you're supposed to do, but in terms of, you probably haven't submitted a big, long math paper before. Okay, it's a little different than what you might be used to. So this is a good way to test it, to see if it's going to work. Okay. So now let me go back again, and I'm kind of going reverse order in terms of timeline. So that you want to have done by Wednesday. What I recommend is by the end of this week, have your sample taken, have your data collected. Okay, so that I recommend by the end of this week, because that gives you enough time to write it up, because it's going to be, writing up takes a long time. It shouldn't take a long time to conduct the survey itself. The big time is the planning and the writing. The conducting should be not too hard if you've done all your planning right. And I want to let you know that if you think you're going to do if you think you're going to do simple random sampling, think again. Okay, it's pretty much always impossible to do simple random sampling. So again, there are a few cases, especially in the second project, where it could happen, but not the first project. So you can do stratified sampling or you can do cluster sampling. Stratified sampling means you're going to have to identify your strata, and strata that might make a difference in the survey question. The strata could be, for example, if it's college students, it could be year in college, it could be gender, it could be ethnicity, it could be age. There's lots of different strata. But if you're going to do stratified sampling, once you've identified your strata, you have to go and find a resource that tells you in the population of your interest, not the sample, but your population, what percent are of each of the types for your strata. So if you're going to be doing it by ethnicity, then you're going to go online probably and find out what percent are Caucasian, what percent are Hispanic, what percent are African American, whatever types you've decided are the kind of the big types or the important types you want to stratify by. So that, and your resource that you find it on, you need to put that into your project, in your bibliography or somewhere. Okay, I don't care whether you have perfect MLA, but you have to cite your sources. So any questions on that? Okay, that's if you're doing stratified sampling. It's not that hard to do stratified sampling if you understand it, and the whole point of this project is to get you to understand sampling technique. Okay, to get you to understand that you don't just ask your friends. You know, you really got to think about who you're going to sample, so you have a representative sample. If you do cluster sampling, you have to identify your clusters. Notice plural. Okay, not just one cluster, clusters. And then you're going to go and you're going to survey everybody in each of those clusters, not some of them, but everybody. And that's how cluster sampling works. Now, your clusters should represent your population. So again, you should think and identify what clusters you want to survey if you're doing cluster sampling, so that you have a good representation of the population. Okay. Are there any questions about the sampling technique? Okay, and then of course, then you go do your survey. What I recommend, if you're going to go in a classroom, a lot of you are going to classrooms, then put it on paper. Don't ask it verbally, because that takes a lot of time. And especially if you're going to be, and you should always ask the instructor first. They'll almost always say yes, but you don't want to take a lot of class time out of it. You just want to hand out the paper, have them write down the quick answer, and then pick them up. And that way you're not ruining another class. Is that clear? Okay, or however you're doing it. Okay, that any kind of cluster sampling, you definitely want to do it that way. Okay, so again, by the end of this week, I recommend having the data collected, and Wednesday again, you should have your rough draft done. Then, kind of continuing backwards trend, I recommend by now, and a lot of you have already done it, and that is post your project idea, if you haven't already done it, on the Project One discussion board. I'll take a look at it, and I'm pretty quick at answering, and then I'll give you feedback. Okay, there's always stuff I'm going to suggest, so that doesn't mean it's a terrible project, it just means I'm always going to have suggestions. Okay, I haven't had any of them where I look at it and go, okay, this isn't going to work, try something different. That could happen, but hopefully it won't. What I recommend, if you haven't already come up with your project idea, is read through others that have posted, to get an idea of what kind of works and what doesn't work, and what I've suggested, so you know what you need to do to make it work. Okay, and that I recommend doing like ASAP. Okay, hopefully you'll have it done tonight, by tonight. It doesn't take that long, but you need to communicate with your partners. That's the most important thing. Okay, so that's kind of the timeline in reverse. I like to go in reverse because, again, you know the due date. So now let's go backwards and get all the things you have to do to make it work. You definitely need to be working on this together as a group. There have been some students that have dropped the class. So if you're looking for a partner, then again, post on the Project One discussion board, say I'm looking for a partner. Communicate with people. Okay, some of you have emailed me. I've said send these people a note, because these people only have 2 now because they lost their 3rd person. That type of thing happens. You need to be working together. You should all be writing the paper. So you might want to section it out. There's going to be different sections of the paper: introduction, talking about the sampling. There's going to be talking about the statistics, talking about the charts, and a conclusion. And each of those is a main piece. It's not like a small paragraph, but a main piece of the paper. So you want to divvy out the different pieces of it. And then, and this is why you want to do everything early, share it with your partners so that you can read it and make sure that you've corrected all the errors before you send it to me. Does that make sense? Because this is a collaboration. A lot of people have found that using Google Docs works well for sharing, because that way you can just edit it. Everyone could be editing it once, and that works well. So a lot of people have found that. You don't have to, it's not a requirement, but that's just something people have done. Any questions? Okay, about the project or about anything else too? Any questions? Again, this is a good time to ask questions. Not hearing any questions, but I wanted to give you a minute. No questions? Okay, I did seek and contact a few students to join the group. Okay, and hopefully you'll find people. I know there have been a few drops in the class, which means there's some groups that no longer have 3 people in. If you only have 2 people in your group and somebody asks to join, please let them in. Be nice, you know what I mean? Don't let anyone like be left alone, because being left alone is awful. You get a big penalty for it. Okay, so you know, if there's only 2 of you, let a 3rd person in if they ask. It's just the nice thing to do, the right thing to do. And you'll have less to do because you'll be able to divvy out a portion of the project to that person, and you have less writing. So look at it that way too. Okay. Any questions? Any questions? Okay. What I'm going to do, last time I realized, because I got a few comments about it, is that when I did things in the chat box, it didn't really work because not everyone could see it if it was posted on YouTube. So I'm going to do things completely on, I'm going to do the math part today on the Paint tool. Okay. You're confused about the practice test. Practice test is just a practice test. Oh yeah, I guess I should mention next week there's an online midterm. It's not as high stakes as the other tests, but it's a good, you know, see if you've got it. And I put a practice test on it, but don't stress about it. That's what I'm trying to tell you, Charles. Just don't stress about it. You know, do your best. If you have questions about any of the problems, post them on the Q&A form, and I'll answer for you. But a practice test shouldn't have a key, because then it's not a practice test, and it's practice problems. Do you see the difference? Because in the test, you don't get a key. You hit submit, and you don't get to retry it. You don't get to see what the answer is and deal with it and change anything. Yeah, it's due this weekend. It's due, yeah, so I'm off a week. Let me double check before I actually say it. And I should announce that, because that is important. There, if you look at the syllabus and also the modules, and you check out the due dates, you'll notice that the, just a minute, let me double check before, there it is. April 28th, yeah, so it's due Sunday, sorry about that, is the kind of the online midterm. The online midterm is going to look exactly like your regular weekly assignments. Okay, they actually come from the same questions. Okay, but you get random problems, so they might be different random problems. So, but there's 2 big differences. One difference is that it's much longer. So be ready for that. Make sure you give yourself enough time. And the other big difference is that you only get 1 try per problem. So when you hit submit, that's it. If you got it wrong, you got to live with it. Okay, because I wanted to make it look like a regular test instead of just a weekly assessment. And regular tests, you don't get another try. Okay, and that's not proctored. Okay, so it's not proctored all under that. That's just it's just like the regular assignments, but it's much longer. Okay, so give yourself, don't wait till Sunday evening. You won't have enough time. Okay, but do the chapter 4 and 5 stuff first. You're not seeing it? Okay, let me go and see it. Let me double check that it's there. It should be. Yeah, it's there. If you go to, maybe I'll share my desktop so you can see it. Let me pop this in. And let's do a share. Just a second. That is that one. Okay. So this is the module page, also the home page. And if you go to week, I see what the problem is. It should be, let me move it. These are all April 28th, so there's week. It got placed in the wrong place. Sorry about that. The good news is I can change it as we speak. There. So it was in the wrong week. So it's there. The online exam, chapters 1 through 5. And that's at the end of this week. So let me unshare. So now you'll see it. Let me go and stop share. Okay. Will it affect severely if we don't pass? So here's the thing, is that it's not a huge part of your course grade, but I purposely put it here to make sure that it gave you a little heads up. I want to make sure that you can do problems without having to do over and over and over again. So if you can't do these problems like that, you're not going to do well in the regular midterm. Does that make sense? So the points on it aren't that big, but it's a big heads up. It's a big reality check. And that's kind of what it's about. Okay, any other questions? These are good questions, though, really good questions. Any other questions? All right, I just muted the eating. Okay, so let's go and do some math. Today is one of the mathiest days. Some of you will like that, some of you won't like it, but today is one of the most mathy days, or this week is one of the most mathy weeks of the quarter. So what I'm going to do is we're just going to do problem after problem after problem, practicing, and talking about how it works. So let's go ahead and share a problem. Find it. There it is. That and that one. Okay. So I have a problem for you, and this comes from chapter 4. And let's take a look at it. So again, one of the things about this class, you might have noticed, is pretty much every problem in the whole class is a word problem. Have you figured that out yet? It's very different than, say, an algebra class. Okay. So this problem says a car salesperson gives out a $10 gift to every customer who test drives a car. 12% of all customers who test drive a car purchases the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchases the deluxe model of the car, resulting in a $300 commission for the salesperson. Write down the probability distribution function for the salesperson's profit. Find the expected value and standard deviation and interpret the expected value. And then, is this a lucrative job? Okay. And what I've learned through my ages of giving this problem is some people don't know what the word lucrative means. So what does the word lucrative mean? Yeah, it means good money. Okay. Good money, nice profit. Not just profit, but nice profit. Okay. If the profit is 1 penny, that's not lucrative. Okay. But it needs to be a nice profit. Okay. So we want to do this. We want to figure out, we're going to write down what's called a probability distribution table. And that's the first thing I need to do. So let's go and do that. So I'm going to draw a table. And you could draw it horizontal, you could draw it vertical, it doesn't matter. But in the table, we're going to have x, and we're going to have p of x. So x are all the different values that can happen. And you guess on what p of x is? What do you think p of x might be? Any thoughts? Like f of x? Yeah, probability. So it's the probability that x happens. So P stands for probability in this class for most of the time. Okay, so what we're going to do is we're going to look at the different things that could happen. Well, one thing is the customer could come in and they can end up buying the base model. So what is the profit if the customer buys the base model? See if you can tell me the profit. Yeah, it's 190. So remember, this is a business piece. Profit equals revenue minus cost. The revenue is 200. The cost is the $10 for the gift card. Any questions on that? Okay, so what we can write, let's do this in nice typing. Is that first value of x was 190. Any questions on that? Okay, what is the probability of that 190 happening? Yeah, 12%, but we're going to want to write it as 0.12. Okay, we're going to be putting this in the calculator, and percents aren't nice to have in the calculator. So don't forget that you want to turn it into a decimal. Okay, another thing could happen is the customer could purchase the deluxe model. What's the profit if the customer purchases the deluxe model? Yeah, that's going to be $290 because it's $300 for the revenue, but the cost is still $10. And what is the probability of that happening? Yeah, that's 0.08 because we need to turn it to a decimal. Is that all that could happen? Are those the only two values of x? What else could happen? What other value of x could happen? Yeah, they could walk away. Yeah, and the value of x that they walk away is -10 because that salesperson just handed a gift card, okay, or a gift that cost net $10, and the salesperson is just out $10. So that's -10. And by the way, this is not some weird thing. This happens all the time. I don't know if you've ever been given a gift to, go into someone's shop or something, but it's really common. Okay, So now we need to find out the probability of that negative 10 happening. And Riley's got the right idea. So the idea here is that we know that if you take all of the probabilities, they add up to 1, right, or 100%. Well, there's a 12% chance they get the base model. There's an 8% they get the deluxe model. That's a total of 20% now. So what's left over is 80% are going to walk away, which is 0.8. So let's put that in. Okay, notice 0.08 and 0.8 are very different numbers. Any questions so far? Any questions? Okay, so now what we need to do, and I'm going to write these down. That's important. So 190.12, 0.12, 290.08, and negative 10, 0.8. Is now we're going to use our calculator. So I'm going to reshare my desktop, go to the calculator. And let me show you how to find an expected value and a standard deviation using the calculator. So what we do is we hit the stat button. We have seen that before. We're going to edit. We're going to clear out L1. And you also need to clear out L2 because this is a 2-column table. This is the first time we've had a 2-column table in this class. So in L1, we had 190, we had 290, and we had negative 10. Now I want to mention something because a lot of people have trouble with this. And it's one of the unfortunate things about the TI calculator is that there is this above the plus and this below the 3. Which one is the negative I want to put in front of the 10? Yeah, below the 3. So it's really important because otherwise you'll get an error. So if you use the other one, that's subtraction. We don't want subtraction, we want a negative 10. Any questions so far? Okay, then I'm going to go and type in the L2 numbers. Those were 0.12. 0.08 and 0.8. Okay, I recommend you do this with me. Get your calculator out, make sure you know how to use your calculator. Okay, once I've got that done, what I do is I go to Stat again. And then I go to Calc. We've seen this before. And it's still a 1-variable statistic. We just had X. So I'm going to hit Enter on 1-variable statistics. There are 2 kinds of calculators for the TI. This kind has list, frequency list, and then calculate as a menu. So the other kind will just say 1var stats with a parenthesis. And I'll mention that in a second. For this kind, my list is L1. If it doesn't say L1, you hit second 1 and enter. Freak list is L2. So I hit second 2 and enter. And then I hit calculate, which is enter. Any questions on the calculator work? Okay. Just a note, if you don't have the calculator yet, you can use a spreadsheet. And when you go to the spreadsheet, you go to 2var stats, put in your 2 columns, scroll very far to the right, and you'll see it. Okay, but again, the calculator does it nicely also. All right, the expected value turns out to be the mean, which is X bar. So X bar is 38. The standard deviation, that's sigma X, which is about 98. Let's call it 98, good enough. Mine only has 1var stats. So this is 1var stats. And then what you do is you type in second 1, comma, second 2, and then hit enter, Bailey. Try that. Again, yours is the older style. It's either the 83 or an older 84. And the good news is my long video has the older style, because I made it a long time ago. Okay. So there's our expected value, and there's our standard deviation. Okay, so I'm going to unshare my desktop, or new share actually. I'm going to go back to our Zoom. Okay, and remember our expected value. Let's type this in so we've got it. Yeah, get to work. You should type in, after one var stats, you might have a parenthesis, second 1, comma, second 2, end the parenthesis, and then enter. And that should work. Okay, I don't have the ability to show it on the screen because I only have the newer one on this screen. Okay, but I do have my other video shows it. So my expected value, I'm going to call it EV for expected value, was 38. And my standard deviation was 98. Okay, so now I want to talk about the expected value. Take a look at that expected value. First thing, just randomly, anyone ever sold cars in this group? Okay, Riley, how long does it take to work with a customer? How many customers do you get an hour, for example, or in a day? Okay. Okay, so if you get 2 customers an hour, then does the expected value look like a good thing? So 38, that's dollars each time you have a customer on average. So are you good with, in an hour, making $76? Okay, yeah, sounds good. Sounds good. So let's write down the interpretation of the expected value. And there's going to be some really important words here that you have to put in, and you will lose points if you don't. So this is one of those that the structure is not optional. So what we can say is that if many customers come to look at cars, then it is likely that the average profit per customer will be close to $38. All right, so I want to mention something very important. Many, necessary. It's not one customer. Okay, if a customer comes, you're not getting $38. You will never get $38 for any individual customer. That can't happen because you either get 190, 290, or negative 10. So we're talking about many. Okay, then it's likely, you don't know that you're going to get $38. But it's likely that. We're talking about an average. It's the average over all of those many customers. And we're not going to get exactly $38, but we're going to get, likely to get close to $38. Okay, so those words must be in there when I ask you to interpret the expected value. Any questions on this? Any questions at all? Okay. Is this a lucrative job? Sounds good, right? But what's the one problem about this job? The hint is look at the standard deviation. What's the one problem with the job? And the standard deviation is kind of highlights the problem. Any thoughts? Yeah, it could be negative. So what that says, the standard deviation is 98. That is high compared to the expected value. You see that? It's much higher than the expected value. So that means there could be days where this salesperson actually doesn't make any money, even though the average in the long run is 98. I mean, is 38 per customer. But there will be days where it could go way below and it could also go way up. So this is the standard deviation tells you, yes, on average for many customers, you're likely to get close to $38. But if you're just looking at a short period of time with maybe a customer or two, you may end up actually just losing money for your job, not even making anything, end up being negative. Any questions on that? Any questions? Okay, just a note, because this is kind of interesting. What industry in Tahoe cares about the expected value a lot? The hint is I made money on both ways. Skiing, not so much. Casinos. Yeah, the casinos. So just to let you know, I've worked both sides of the casinos. So I made money with a positive expected value. Any guess how I did that? Card counting, exactly. It wasn't dice, actually. You can't make money in the long run on dice. So I made money card counting. I did that until they told me they were going to kill me. And then I decided I better stop. And then I made money on the other side, and that is I worked for the casinos, making it so people like me can't make money. So if you lose money in the casinos, it's my fault. But I made a lot of money doing that, so I don't feel too bad. So just let you know, they want the expected value to be about negative 8%. Okay, and I'm telling you that from my experience as a consultant for the casinos, because they wanted us to do that. I used to actually have a class on statistics of gambling, but I haven't taught that in a long time. Yeah, it takes a lot of work, but you can't win up in Tahoe because I made sure you can't. Okay, yeah, it was like the movie. Yeah, but the movie was false. They didn't actually beat anybody up. The MIT people actually did what I did. They didn't play again because they were like didn't want to get killed. But they threaten you is what they do. Okay, so anyhow, figured I'd tell you the expected value is really important. The expected value is negative, it's a bad idea. The expected value is positive, it could be a good idea, but you should be thinking about those standard deviation to tell you whether in the short run you're still going to do well. And if the standard deviation is low, then in the short run, you'll still do well. If the standard deviation is high, then in the short run, you may not do well. In the long run, you'll always go, or you're very likely to be close to the expected value. It's not a big issue. That's called the law of large numbers. Any questions at all on this example? Any questions? Okay, I think I want to do one more because we have some time of these before I move on. Actually, let me go to the other type. One more from this section, but it's not going to be expected value because they're all similar. So let me go ahead and get rid of it. Let me know, by the way, last chance if you need to see it more. Let me go to, where is it? Select. There it is. Because I need the space. Okay, now let me pop another one in. I'm going to use this one because this is the most important. I might do another one too. Okay, never does the AB right. Okay, so here's a new question. We'll get partial credit on a test if we set up the chart right, but our final, yeah, I always give, and vice versa. If you get the final answer right, but you do the calculations right, but your chart wasn't quite right, then you'll get partial credit. So I give credit for the steps that you show. So each step gets some points. Okay. The computer might be a little different because the computer, sometimes it's all or nothing. Computers can't like read and figure out if you got the idea, but you missed something. But when it comes to the big stuff, that's the midterm and the final, I give partial credit. Okay, so let me read this question. 21.2% of high school seniors have used marijuana. Must be true because I read it on Google. Just kidding. But I did find it somewhere. Okay, suppose a study of 200 high school students in states that have legalized marijuana for recreational use found that 49 of them have used marijuana. Is this statistically significant? Hint, find the probability that at least 49 of 200 have tried it. Okay, now I don't expect you to understand right now all of these words, but that's why I'm here. I'm going to explain them. So this is really what this class is all about. What we want to do, and this is why we care, what we want to do is a study is conducted, we want to look at the results of the study, and we want to say, well, do we have good evidence or not? So it turns out that if the probability is kind of the standard less than 5%, we say it's statistically significant. All right, so I'm going to pick this apart a lot. What is the survey question for this particular problem? What's a survey question? See if you can type in the chat box what the survey question is. Yeah. Okay, good. I'm glad I'm getting both because I want to specify what the survey question. The survey question is, have you smoked marijuana? Okay, the survey question is, what are you going to ask this individual high school senior? And it is, have you smoked marijuana? You're not going to ask that senior what percentage of seniors use marijuana. You're going to ask that person, have you used marijuana? Okay? Any questions on that? The question of the study is the percentage of seniors who have used marijuana, but the survey question is, have you smoked marijuana? All right, so I'm going to ask you, have you smoked marijuana by the time you were a senior in high school? Put your answer. Okay, and I want to emphasize that we're getting a lot of yeses and nos, and that's all we're getting. This is a yes-no question. And in this class, it's really important to be able to categorize the question on whether is it a yes-no question, is it a question with a number answer, is it a question with some other interesting word answer, like what is your favorite color kind of question. If it is a yes-no question and we're conducting a survey, the distribution is called discrete. Okay? So this is a discrete distribution. So you can't have, say, 3.78 high school seniors have tried marijuana. Either you tried it or you didn't. Does that make sense? So a discrete study means there's a certain number that could happen. And our question is, how many, so the question of the study is how many have smoked marijuana, and that's discrete because either 0 or 1 or 2 or 3 all the way up to 200. You can list all the outcomes. Sometimes you have to list it with ... but you can list them. And if you can list all the outcomes, we call it discrete. So in the expected value problem, that was discrete also, because there were only 3 different possibilities for the car salesperson, right? There was regular car, deluxe car, and walked away. 3 different choices, and there were numbers involved for each of those choices. So you could list those numbers. So that's a discrete distribution. Here, it's 0 through 200 for the final answer to the not to the survey question, but to the study. All right. When we have a discrete distribution and we want to find a probability, what we can do is we can use what's called the binomial distribution. So I think I want to type that because it's that important. That's the name of this. So binomial distribution means probabilities for discrete distributions. Any questions so far? Okay, so we want to find the probability that at least 49 out of 200 have tried it. All right, so I got some bad news for you. For most calculators, the calculator can't do at least 49. It can only do less than or equal to. Any questions on that? Okay, so we want the probability, get that text in there, there we go. We want the probability that x is at least is greater than or equal to 49. Any questions on how you read at least and it says that? All right, the bad news is most calculators can't do greater than or equal to. It can only do less than or equal to. So any suggestions on how we can handle this problem and make it a less than or equal to? Okay, less than 50 doesn't quite work. First, it has to be less than or equal to something. And here's my suggestion. We want less than or equal to, which means we're going to have to use rule of complements. And we have to decide the complement of greater than or equal to 49. So what I recommend is the following. One more time. Just blindly write down some numbers. How about 47, 48, 49, 50, 51. Then, if we look at what is greater than or equal to 49, that includes 49, 50, and 51. Is that clear to everyone? So you're right, Brenda, we're going to be doing 1 minus p, but we got to understand what the p is of. So now, what is the complement of what I've circled? What's the highest number that hasn't been circled? 48. Okay, so this is where a lot of people have trouble. So that's why I like to take it a little bit slower and show you that little diagram. Oops. One more try. I'll do text. So what I can say, as Brenda mentioned, this is 1 minus the probability, oops, am I right, equal, 1 minus the probability that x is less than or equal to 48. Any questions on that? Okay, notice that our sample size was 200. And our probability of them saying yes, sometimes we call it success, even though success isn't always a good thing, by the way, in this particular subject. The probability of them saying yes, or the probability of success, is 21.2%, but we want to write that as a decimal. So how do you write that as a decimal? Yeah, 212. 0.212. Any questions on that? Let me write this down because we're about to go to the calculator. Okay, so now I'm going to go to the calculator and we're going to calculate this out. So first thing, let's clear out what we have. Okay, so we want this probability. First, I'm going to go 1 minus. We know we need to do that. And then what I'm going to do is I'm going to go to second distribution. That's that VARS. See above that DISTR? That's the distribution. Now I'm going to go pretty far down. And I'm going to use binom CDF. Okay, so the question says 21.2% of seniors try it, but the study says 200 regular high school students say it. Yeah, so the 200 is the sample size, 21.2% or 0.212 is the probability of success for each person. Okay. Yeah, we're looking at seniors. If I put everything in the study, it wouldn't fit on the page. So sorry if it doesn't have all the different aspects. I can't tell you a whole biography of the whole study. So we're just assuming that everything worked. Okay, but the numbers I gave you, those are important. So I'm going to go binom CDF. Just a note, binom CDF is the less than or equal to category. Binom PDF is the exactly equal to category. And yes, you're going to have to do some exactly equal to's also, and then you're going to hit the binom PDF instead. But this example, CDF. Okay, the newer type of calculators do it this way. Number of trials is 200. E was 0.212. The X value, that's the 48. And then I go down to paste. And you'll see we have that 1 minus binom CDF, 200, 0.212, 48. If you have the older kind of calculator, it's just going to pop in binom CDF with a parenthesis. You type in 200, 0.212, 48, and the parenthesis, hit enter. Then I hit enter. And I get 0.1459 or so, about 15%. Any questions on that? Okay, so now I'm going to go back. And we had 15%. So let me write this down. That's 0.15. And note that is greater than 0.05. That was a number that we're going to compare it to, because that's what statistically significant means. We're going to be using this a lot in this class, by the way. So what we say is that the results are not statistically significant. Any questions on that? Okay, I'm not going to do part B, but I will tell you that it said, would your answer change if you found out later that some students lied? You think students would lie about smoking marijuana? Yeah, of course they would, especially if their parents might hear about it. Okay, and actually 54 of them have used marijuana. It turns out that if you did it with the 54, which by the way would be a 53 when you did the whole circle thing, you'd end up with a number less than 0.05, and then it would be statistically significant. I'll let you do that on your own. Any questions on this example? Okay, so now I'm going to do another example. Back to the calculator real fast, just a second. Okay, there's the calculator. Okay, and I'll let you look at it a bit. Good, good. Okay, so now I'm going to do another example. Which means I got to erase this and put the next one in. That is select, grab, backspace, pop the next example in. And we'll see if this all fits. You know what? It's not going to fit, so I'm going to do a piece at a time. Okay, so what we got here is suppose the time that students spend in the math center is uniformly distributed between 110 and 120 minutes. Be sure to show your uniform distribution charts. If a randomly selected math lab user, okay, is observed, find the probability that the student will spend between 30 and 70 minutes in the math lab. How is this different from the problems that we just did? What's the main difference? Yeah, it's not discrete this time, right? Because it does make sense that someone might have spent 12.73 minutes. Do you see that? So this is what's called a continuous distribution. Any questions on that? So continuous distributions are very different than discrete. We can't use the binomial because binomial is only for discrete, but it does say it's uniform. So the key on this one is I can draw the picture. And the picture is nice because one thing about using this paint is it lets me do what I need to do, and that's draw a rectangle. So when you have a uniform distribution, this is still going to be a CDF actually, because there's no, PDF is for exactly. And it turns out when you have a continuous distribution, whenever you hear a probability of exactly is always going to be 0. So I won't ask you one of these on this. Okay, but what I can do is I can draw a picture. That I can always do. And when you have a uniform distribution, the picture is always a rectangle. This is why we're doing uniform distributions first for continuous, because rectangles are the easiest geometry there is in terms of finding area. I hope y'all agree. So in particular, I'm going to type in 30. And 70. Any questions about my rectangle so far? Oh, sorry, I got it wrong. Let me do it again. It's 10 and 120. Because the very lowest you could be is 10, and the very highest you could be is 120. Okay, the next thing I need to do is I need to find the height of this rectangle. So let me just draw in H. H for height. Okay, so let me ask you something. If it's uniformly distributed between 10 and 120, that means everybody does it between 10 and 120. Then what's the probability that a randomly selected student will be somewhere between 10 and 120? The hint is it's very easy, this question. Yeah, but yeah, 100%, it's better to write as a decimal though, which is just 1. Okay? Now, when you have a continuous distribution, the probability of being between two numbers is the area. And that is very important in this class. So the good news about this distribution is it's a rectangle. And I'm hoping you all remember, how do you find the area of a rectangle? Yeah, we do length times width. I like to use base times height. And the reason is L looks too much like a 1, but if you like length times width, you can. But I like BH instead of LW, but whatever works for you is fine. So what I'm going to do is I'm going to do a little bit of math, basic math. So our area is 1. Because there's a 100% chance, right, which is 1, of being between 10 and 120. So the area is the base times the height. And the base, how do you find the base of this rectangle? Again, not too hard. Yes, 110, but let me write it down. It's 120 minus 10. Is the base of this rectangle. The height is h. Any questions on that? So now what we can say, 120 minus 10 is 110. H is equal to 1. I told you today's going to be a bit mathy. So how do we solve for h? Yeah, we divide both sides by 110, and we get h is equal to 110. 1 over 110. And there's our h. Any questions on the math so far? Okay, so the next thing I do is I answer the question. If we have someone and we want to find out the probability they're going to spend between 30 and 70, we need to find that probability. So let's do that. And to do that, let's go into 2D shapes. And it is between 30 and 70. Something like that. Let's label them. Okay, so I want to find the probability that x is between 30 and 70. And the good news is it's not that hard. So the probability that 30 is less than x is less than 70. Well, as I mentioned, the probability is always the area of that piece. So that piece is a rectangle. Is that clear? And we know that that's going to be the base times the height. How do we find the base of this rectangle, this smaller rectangle? Yeah, 70 minus 30. And the height we already found was 1 over 110. Put some parentheses to make it look like or a times sign. And make it come out. There we go. And that is just what, 4/11ths, if you do the math. Any questions at all on this example? Any questions? Okay, now let's do another example. So I'm going to erase a bunch of stuff. You still have this. That's not going to change. But let me go ahead, get rid of this question, and pop a new one in. But we're going to start with the same idea. Okay, find the first quartile for the time that students spend in the math lab. So who remembers what the first quartile means? It's not the minimum. It's a good try, though. Yeah, it means that 25% is to the left of that value. So what I'm going to do is I'm going to draw another rectangle. And what I know is that the area of that rectangle is 0.25. Any questions on that? And I want to find out this value because that's going to be the first quartile. Let's call it x. Have I lost anybody yet? Okay, so next thing I do is I go ahead and use the area formula because that 0.25, that's the area of this rectangle. So we can say the area is equal to 0.25, but that is equal to the base times the height. What is the base of this rectangle? What's the base of this rectangle? And this is a bit of a harder question than the other ones. Any thoughts? I'm not looking for a number, that's a hint. Okay. All right, so the base, the way you do is you go right minus left. Right is x, x is 10. So the base is x minus 10. Any questions on that? Any questions? Okay, and then the height is 1 over 110. Put it. And that is equal to 0.25. So what we could say is x minus 10 times 1 over 110 is equal to 0.25. Okay, now it's time for algebra. What can we do? We want to solve for x. Again, my warning today was we're going to do some actual math today. You could distribute, but that's probably not the best thing to do first. Distribute is not wrong, but it's harder. Use a calculator. No, that won't always work. Yeah, So Julian, you're kind of right. That'll work, but easier is multiply by 110. It's easier to say. So I'm going to multiply each side by 110 to get rid of the 1 over 110. So let's do that. And we have x minus 10 is equal to 0.25 times 110. All right, now comes the easy part. What's the last thing I have to do? Yeah, I'm going to add 10 to both sides. And when I add 10 to both sides, I get x is equal to 0.25 times 110 plus 10. That you want to put in your calculator, or you can do it in your head. So that's what 27.5, 37.5, if I did it right in my head. Any questions on that? Any questions? Okay, so a lot of math. Okay, it's definitely some math to do. Okay, I have time for one more problem. So let's go ahead and do that. I'm going to go and erase this. This one's going to have some similarities, but it's going to be very different. Okay, so it says, suppose the number of ounces of water that people drink from the drinking fountain is uniformly distributed between 1 and 8 ounces, and that the number of ounces of water that students use to fill their bottles in the drinking fountain is uniformly distributed between 4 and 16 ounces. So by the way, I filled this bottle in drinking fountain. We have a little bottle filler. You watch Thorne take a 2.5 ounce drink out of the drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain or the corresponding water usage? Okay, so let me ask you something. What is this question asking you to do? See if you can come up with it. And the hint is chapter 2. Yeah, but what about chapter 2? So we are comparing them, but how do you compare them when they're totally different? One is drinking out of a fountain and the other one is using a bottle filler. We want to say which is more unusual. Dependent, good try. Actually, that's chapter 3, Candia. Remember? Going once, twice. Okay, if you want to find out which is more unusual, and they're kind of different stuff, use a z-score. Do you remember doing that? So this is a question to find the z-scores. Okay, so now let me remind you. I think I got to do it with a brush because there's messy writing. So z is equal to x minus mu divided by sigma. Hopefully you remember that. It happened in chapter 2. Mu is the mean, sigma is the standard deviation, and x is the value that you saw happen. But then we need a little more. We need to find the mean for a uniform distribution. It turns out the mean for the uniform distribution should make a lot of sense, because if it's uniform between here and here, then the mean should be right in the middle of them. Does that make some sense? So the mean is the average of the left and the right. So let's write that out. So mu is equal to A plus B divided by 2. Because that's how you find the average of two numbers. You add them up and divide by 2. Any questions on that so far? Okay, then there's the standard deviation. And all I could tell you is that if you haven't taken calculus, you have no chance of coming up with this. And if you have, you still probably have no chance. But at least I could prove it to you and you might understand it. Sigma is the square root of B minus A, in parentheses, squared divided by 12. And the 12 is inside that square root, so it's a very long square root. Okay, again, you're not supposed to know how I got that. Okay, but if you want to learn how I got it, take calculus and beyond, and then you'll learn. What you do need to know is just the formula. So now let's go and calculate these scores. Calculate the z-score. So let's start out with Thorn. Thorn took 2.8 ounce drink from the drinking fountain. Okay, let's go to Thorn. I'll do Thorn in this blue color. So Thorn, call Thorn T. That x is 2.5. I guess I could have done with text typing. Mu, well, Thorn used a drinking fountain. And the mean for the drinking fountain is going to be the average of the low and the high for the drinking fountain. And we know for the drinking fountain, it's between 1 and 8. So 1 plus 8 over 2. And that's 4.5. And then sigma is the square root of 8 minus 1 squared all over 12. Okay, that one I can't do in my head. But I could estimate it in my head, but I'm not going to do that. I can go in, I'm just typing it into the Google bar right now. And that's 2.02. Any questions on that? Okay, so now we can just plug in. Let's see if you guys can plug in. You're taking 2.5 minus 4.5 divided by 2.02. And I could do this one in my head, actually. See what you get, approximately. Because you're putting into the z-score formula. So type in the chat box what you get when you're plugging in the x, the mu, and the sigma into the z-score formula. All right, shouldn't be that bad. Yep, we're looking for z. So put in the z-score formula. I want to give you a chance to do it. If you just watch me, that's not as good as you trying it yourself. And I've done all the hard work, which is get x, mu, and sigma. Now you just plug in. Yeah, or how about -1, Juliana? -0.99, that's close enough to -1. Okay. All right, let's do the same thing, but now we're going to do Preston's. Can you show us? Okay, it's just very simple, 2.5. There's nothing fancy here, I promise. Minus 4.5 over 2.02. Okay. That's all I did, Bailey. All right, so now we got to do Preston's. So let me change the color for Preston. How about green? So for Preston, same thing. X, in this case, Preston did 5 ounces. So it was 5. The mean. So again, Preston now is doing the water bottle fill. Okay, and that's between 4 and 16. So the mean is the average of 4 and 16. 4 plus 16 over 2, which is 10. Just quickly did that in my head. And sigma is equal to the big L square root 16 minus 4 squared over 12. Any questions so far? And I got a 3.46 for sigma. Sorry, that's a 16, not 11. That's just, I'm trying to do this with a mouse. So about 3.5. And now we just pop it in. So we have x, which is 5. Minus the mean, which is 10. Divided by the standard deviation, which is 3.5. And that's 1.42, negative 1.42. Okay, which one was more unusual? So whose was more unusual? Yeah, Preston's was more unusual because it's farther from 0. Okay, so Preston was more unusual. Negative 1.42 has a z-score that's farther from 0 than negative 1 is. All right, what I need to do is I need to give you a secret word. So I need some space. Let's, I gotta put it somewhere. Let's get rid of some of this. There we go, select. Just get rid of this part. And let's do a secret word. How about in red? Let me do red, just a minute. And the secret word of the day is likely. And the reason why it's likely is, if you remember when we talked about the expected value and we want to interpret it, likely was one of those words, right? Many things, if you do the trial many times, then it is likely that the average will be close to the expected value. Okay, so it's 7:26. I made it by 7:30. I always try and make it in between an hour and a half. That's kind of my standard, so I don't kill y'all. But as always, I'll be happy to answer any questions about the project or anything else. Let me stop the share. So the secret word is likely. And as always, if you have any questions, I'll be happy to answer them. Or if you don't, you can say goodnight. That's fine too. Next week was Monday because there were actually 2 requests for next week, no request for this week, last week, which was interesting. So I decided, well, I'll take the request for next week. So next week is going to be Monday at 6, by the way. So I don't want to always make it Tuesday because then I'm shutting out people that can't make it on Tuesdays. But we do get a bunch of people here, which is good. So Tuesday seems to be working pretty well. So we'll probably do Tuesday and some other weeks. Okay, any other questions? Again, you can talk them. You can unmute yourself and talk, or you can type in the chat box if you have questions. Or you can say goodnight, that's fine too, whatever works.
Professor, I have a question. What if I don't hear from anybody joining their groups?
There are people with only 2 in a group. So ask those people.
I did, but if I don't hear because I'm losing the time, so I would know what I need.
Keep asking them. Keep asking them. And by the way, if you only have 2 in your group and you don't take on someone that asks, I am not going to treat you very well in terms of partial credit. So if there's only 2 of you guys, and I know we've lost it, today we lost a couple students. So I'm going to be pretty forceful. And I'm trying to think if any of them are here. I think so. So if you only have a group of 3, yeah, max is 3. So if you have a group of 3, that's fine. If you have a group of 2, please take Zach in. Got it? And you know who you are. I think I'm not going to call out names, but you know who you are. Some of you are here, I believe. So, okay, Abigail just says you can take Zach. So Zach, you got it? Okay, figure I could be pretty forceful. It's better to have 3 anyway. There's less work to do. And then make sure you communicate with each other, get each other's contact information. You could chat through Canvas or Skype or whatever works for you. Okay, if we have a question about sampling for a project, you could ask right now if you want. You could just say it, Allison. Or you could put it on the project discussion forum. Obviously, for the last hour and a half, I haven't been looking at the project discussion forum because I'm here. But I look pretty often. I do want to remind you that Saturday, this coming Saturday, and the following Saturday especially, I'm not going to be online much. I have back-to-back conferences that I'm the chair of. So those have to be priority for those Saturdays. So just let you know. So if I don't get back to you on those Saturdays until Sunday, you know why. It's because I'm in these big conferences and I'm in charge of them, and there's like 100 people coming from all over California. As I mentioned, the following one, I'm trying to get as many faculty as possible to not charge $300 for a textbook and instead use the free book like we're doing. So, and that's from all over California. So that's what that's about. But just let you know, so I apologize if I don't get back to you on Saturday. But every other day, I will be checking, you know, on and off each day. Where can you find your sheet? So the Google Sheet. Okay, so let me share my desktop. Discrete random application. Okay, Brenda, I don't know why you did it privately. Discrete random variable application is based on our homework. Yeah. Chapter 4 is the discrete. Chapter 5 is the continuous. And you have both of those this week. So let me share my desktop. This is the Canvas. You could do it. There's a bunch of ways of doing it. If you go to syllabus, might be the fastest. I think that's where it is. It's been a while since I've been bothered looking. I get it through my Google. There we go. See information on computer spreadsheets? You click there. And you click this first one. And you click this one. And then you have to go to File and make a copy. And what I've found that if you have like a Gmail account, if you're logged in your Gmail account, things work better. You got kicked off? Okay, one more time. Okay. So again, if you're at the syllabus, and there's more than one place you can find this, by the way. But if you're at syllabus, you go to the projects. And you'll see information on computer spreadsheets. Click that. And then Google Sheets, statistics package written by me. And then it's this link right here, this ugly Google Doc link. That's why I can't tell you the link, because it's just a mess. And then you have to go to File, make a copy. Give it a name and hit OK, and then you've got it. And you have it forever. You only do that once, and then it's in your Google Drive. But Bailey, is that clear? Okay. Other questions? Other questions? Let me unshare so I can see you guys. Okay, Zach or Brenda or Bailey or Alex or Constance or 0049. It might be one of you anyway. Or, oh, there's also TM. Other questions? Again, you can just say them, or you can put in the chat box, or you can say goodnight. Okay, have a good night, Constance. Thanks, Tiam. Tia. Zach, any more questions? Okay, so if you're all said goodnight, I'm going to say goodnight too. And for all of you who are watching this as an archive webinar, please post on the project discussion forum any questions you have. And definitely if you haven't already done it, your project one ideas. And if you have other questions, post on the Q&A forum, or if they're private, email them to me, and I'll be happy to answer. So take care, and then I'll hopefully see you on Monday for next week's webinar. So have a good one.